The purpose of this screencast is to learn how to factor trinomials, and to get started I'd like for you to work these 3 warm-up questions. Go ahead and pause the video, work the warm-up questions, and then we'll discuss. Alright, now hopefully you've had time to work your 3 warm-up questions. To start with, the number 72 is a rather large composite number, and so it's going to have lots of factor pairs. I've got them listed out for you here, and the method that I use for listing out factor pairs is I like to start with 1 and then work your way down until you turn the corner. What I mean by turn the corner is I went 1, 2, 3, 4, 5, 6, 7, 8, and then all of the numbers that were factors, we found the pair, and then once we got past 8, we noticed that 9 would be our next one. 9's on the other side, so we've turned the corner. We know that that number is, or that list of factors rather, is now complete. Usually you'll turn the corner around somewhere close to the square root of that number, if you know anything about square roots. Now I notice, or rather I hope you noticed, the word integral means where the factors are all integers. Integers are positive or negative counting numbers, so we would also want to include all of the numbers like 1 times 72 and -1 times -72, -2 times -36, etc. So kind of keep in mind that when you're making this list of factor pairs, you want to include positives as well as negatives. Second warm-up question is just a matter of FOIL. So we're going to be talking quite a bit about FOIL in this lesson. We work out a FOIL problem by doing first, outer, inner, last. The outer and the inner, of course, combined together as like terms. So 3y times 2y would be 6y squared. 5 and 3y would make 15y. The inner 2 would be 8y, and that's going to make for a 23y. And then the last times the last would be 20. And again, that's just first, outer, inner, last. And then number 3, wanting to make the distinction between a positive times a negative and a negative times a negative. So 9 times 6 would wind up giving us 54. Negative 9 times positive 6 would be negative 54. And then here, negative times negative would be positive. So again, we've got our 54 there. Just practicing, reminding ourselves about how to get a positive versus a negative product. Now, with our warm-ups out of the way, I'm going to focus in this screencast on learning to factor trinomials that are of the form 1x squared plus bx plus c. A more generalized form for this would be ax squared plus bx plus c, where a, b, and c are all numbers. A in these examples is always going to equal 1. This is the easiest type of trinomial to factor out. There are some more difficult, some more challenging ones that we'll talk about in a later screencast. I want to remind you that to factor something is to write it as a product, as we've talked about. And in the second warm-up question, we discussed this concept of FOIL. We talked about first, outer, inner, last. And in this picture, you'll notice that as we multiply, as we do a FOIL, x times x, for instance, that x times x produces the x squared, which is our first term of the trinomial. And then when we do our outer and we do our inner, that's where we get that linear term, that term in the middle. So we would end up with 3 times x and 2 times x. And as you've noticed, those oftentimes, the o and the I, go together. And then when we multiply our last times our last, 2 times 3, that's going to equal 6. And that's where we tally all that up. We get x squared plus 5x plus 6. That's how you FOIL. You guys know that at this point. The reason that I'm bringing this up is because we're going to be focusing on the reverse of that FOIL. So in other words, we're going to be taking a number like 6, and we're going to be asking the question, well, how was that 6 in my answer? And it came about from multiplying the last times the last. So when you think about the number 6, you need to think about how many factor pairs are there. For instance, you could have 1 times 6 or 2 times 3, -1 times -6, or -2 times -3. And of those 4 factor pairs, the goal is to get a 5. And so that's why we would obviously choose the 2 and the 3. So in unfoiling, we focus our efforts on the L. We look for 2 pairs of factors, or 2 factors rather, 1 pair that add up to give us that linear coefficients. And that's the gist of how this factoring technique will work out. I've got 10 examples for us to consider, 2 of which you see on your screen here. Let's look at both of these together. The first one I'll kind of do myself here. We're going to look at 24. 24 being the constant, I want to find all of the factor pairs of 24 because, again, with it being that last term in the polynomial, in the trinomial, it's going to be, its 2 factors are going to comprise the 2 last terms in each binomial for part of my answer. So 24 could be 1 times 24, 2 times 12, 3 times 8, 4 times 6. 5 doesn't go in, 6 does, but it's already on my list, so I've turned the corner. I know that's a good exhaustive list. And then, of course, we could include the negatives. Negative 24, negative 2, negative 12, negative 3, negative 8, and negative 4, and negative 6. Sorry about that, I had to plug my computer in. Now, I want to make you aware of the fact that you don't always have to make this exhaustive list of factor pairs. This is really when you're only first learning how the process works. Then usually you can use your inspection, use your eyes, and kind of determine which pair of factors is going to add up to that 11 in the middle. Okay, you could probably already see it's going to be positive 3 and positive 8. So the way we would write up our answers, we would say, okay, that's going to be a binomial times a binomial, a FOIL problem, in other words. X times x, again, because that's how we get our first term. That's how we get our x squared. And then we're going to use a plus 3 and a plus 8. The order doesn't matter as far as those binomials go, because, of course, you could use the commutative property of multiplication to rearrange them. And again, you don't have to make your entire list. We actually could have scrapped this second list, noting that the linear term was positive, and we knew, therefore, we were going to have 2 positives as far as the factors go. Look at example 2 with me now. We've got the number 28. Can you think of 2 factors of 28 that when we add them together are going to equal negative 16? Have you found them? Well, it won't be 1 and 28. It won't be 2 and 14. It won't be 4 and 7. Because that negative is there, it won't be any of these 3. It will be from this other list, negative 1 times negative 28, negative 2 times negative 14, or negative 4 times negative 7. And hopefully you've identified it already. It's negative 2 and negative 4. So the way I would write my answer up in this case is that I would say, hey, my binomials are going to be y minus 2 and y minus 14. Okay, I would encourage you to check your work. Double check your work by foiling it out. You should get the answer to match up with what you started with. If you foil it out and you don't, then you've made a mistake along the way. Let's get you to try this one on your own now. We've worked a couple together. Pause the video, work out example 3 on your own, and then compare your answer with what we get here in a moment. All right, so hopefully you've had a chance to work this out. There's 2 factors of 30 that add up to 31. Hopefully that it's, at this point, it's getting a little bit more easy to find, a little bit easier to find the pair of factors. In this case, we're looking for a plus 1 and a plus 30. Because of all of the factors of 30, we've got 1 times 30, that first pair that gets the job done for us, because 1 plus 30 makes for that 31. Check your work with FOIL and you'll notice what you've got. Now there's an interesting side example to be had in a problem like this, and I might write it up something like this. I might say z squared plus k times z plus 30. All right, and I might ask you, hey, what all values of k would work such that this guy would factor out? Okay, so obviously 31 is an example of a value for k that would work, but there are others. Let me slide this over and show you what I mean. If I made my exhaustive list for the factor pairs of 30, I would include 2 and 15, 3 and 10. I'd include 5 and 6. And I'd also include all the negatives, negative 1, negative 30, negative 2, negative 15. You get the idea. Negative 5 and negative 6. And all you would have to do to figure out all the possible values for k is to just multiply add those numbers together. They all multiply to give you 30, and then they'll all add to give you different values for that linear coefficient. So we would have 31 if we picked the first pair, 17 if we picked the second pair, 13 if we picked the third pair, and 11 if we picked the fourth pair. So we would say, as far as k goes, k could be positive or negative 31, positive or negative 17, positive or negative 13, and positive or negative 11. And the reason we're doing positive or negative is because you've got the two rows of factor pairs right there to choose from. So I would, if I were you, I would make a note of this sort of little side example here. And this is making you think sort of on a higher level, as far as it's not just a rote memorization of how to factor. You really have to understand the method of what's going on behind there. Now, I want you to notice in those first two examples how we had actually the first three examples, we had a positive constant, a positive last term. And so in all of our answers, you'll notice that the signs of these binomials were the same, a couple of positives or a couple of negatives each and every time. And as my note says right here, that's because that last term was positive. However, when the last term is negative, the factors are going to have different signs. You look at your next two examples, okay? And I can already tell you it's going to be x plus something and x minus something. Because think about it. Excuse me, not x plus something or x minus something. Hold on one moment. All right, sorry about that. I just wanted to make sure I wasn't being crazy. This was supposed to be a negative 8, so I had to change that in my notes. So the idea is now that 8 is negative, we're going to have one term be positive, one term be negative, so that when we multiply last times last, we do in fact achieve that negative constant term. So again, nothing else is changing. We're going to look at our factor pairs, and 1 times negative 8, 2 times negative 4, 4 times negative 2, and 8 times negative 1. You pick the pair that works. What do you think? 4 and negative 2 it is. So we have x plus 4 and x minus 2 will be our answer. How do you check your work? You FOIL it out. So with example 5, kind of similar. We got 39. Okay, we could have 1 times negative 39. We could have 3 times negative 13. All right, and already I notice, 3 and negative 13 work. So this one's going to be y plus 3, y minus 13. Okay, this type of factoring technique is very straightforward, very basic, and really with just some drill and kill, practice, lots of examples, you can get the idea of it. With example 6, pause the video if you're watching at home and go ahead and try it on your own. All right, so hopefully you identified the proper pair of factors here. It's going to end up being a 5 and a 6, and notice which one should be positive and which one should be negative. The 6 is going to be positive, and the 5 is going to be negative, because I want, when I do the outer and the inner, I want the outer and the inner to combine to give me that positive 1 that I've got there as the linear coefficient. So very good. Always check your work by multiplying it out, and you should get what you started with. For the last couple of minutes, I've got some curveballs I want to discuss with you. Examples 7, 8, 9, and 10 are a little bit of some tougher ones. So example 7 starts off with you got 2x cubed, which is a little bit different. Everything else has been, even way back at the very beginning, we mentioned it's kind of this form right here where it's ax squared, a quadratic trinomial. Yet down here with example 7, we've got a cubic. Now this should tip you off to the fact that there's something going on here. There's a little bit of a twist, a little bit of a turn. In my hint here, I say bread and butter. You'll remember I kind of referred to our GMF or our GCF as a bread and butter factoring technique. You do it every time. You check for it every time. And so what we'll notice here is that at the very beginning, I should take out a 2x. If I factor out a 2x from each term, I'm going to be left with x squared minus 3x plus 2. All right, and now the remaining 3 terms, that trinomial is now very much factorable from today's earlier examples. We would have an x minus 2, and we'd have an x minus 1. Those are the 2 factors of positive 2 that add up to negative 3. However, one thing I want to make mention of is that students will oftentimes forget to include that GCF that they factored. A lot of times they just kind of throw it out. You might have heard the expression, don't throw out the baby with the bathwater. What that means is we don't want to just get rid of the GCF. It's very much a part of our answer. And in fact, once we multiply everything back, if we didn't have that GCF, we wouldn't get what we originally started with. So that's one type of curveball. Let's look at example 8, second type of curveball. And actually, you know what? I'm seeing my writing here in the green. What I mean by define completely just means don't stop at the first step. To factor something completely means to factor it until each and every factor is irreducible or is prime or cannot factor anymore. We can't take 2x or x minus 2 or x minus 1 down any further. So we have done what's called factoring it completely. And that's an implied instruction. When you see the word factor, the instructions, they are implying that you should factor completely. So just keep that in mind. You got to take it down all the way. So with example 8, what we'll notice, the hint says commutative, and hopefully you notice that the commutative property of addition is at play here, so where I can reorder my terms into a more conventional way of writing the problem out. Here I've got y squared first, that's my quadratic, and then the linear term, and then the constant, and now it's just a simple matter of, okay, y plus 3 and y plus 4. Found my two factors of 12 that add up to 7, and that's not much of a curveball at all, but still, sometimes when the terms are reordered, we get a little bit nervous. Last example that I'll work for you, and then I have an example 10 that's a little bit of a conglomeration of everything that we've talked about. This example here with example 9, it's got a couple of variables. It's got an A and a B. So I'm going to encourage you temporarily ignore that variable. Temporarily ignore the second variable. In fact, pretend like this is a brand new problem that's much simpler. Pretend like it's a squared plus 11a minus 26. Well, by now, if you've been paying attention, you could factor that out. We've got a minus 13 and a plus 2. Actually, let's make my 13 positive. Excuse me, I misread that 11. And let's make that 2 negative. There we go. Because when we do our FOIL, we want the outer and the inner to achieve that positive 11, just like we've got. Now, the only thing I have to do to get my answer is to go back and to put the b in there right at the end, so that the last times the last will give us not just negative 26, but negative 26b squared. So it's a plus 13b and a minus 2b. All right. And again, you can FOIL that to check to make sure you got what you started with. And finally, we come to our last example, and I'd like for you to pause the video, take some time, and look at this bad boy and see if you can figure it out. It's not too complicated if, as my hint suggests here, you actually combine all three of the previous examples and their hints to work it out. Let's see how you do. Pause the video, and then we'll pick back up together. All right, so having had a little bit of time to work this, hopefully you see what to do. Here we're going to put our x to the fourth z squared term first, and then our 10y squared z squared, and then lastly, oh, you know what, actually, now that I'm remembering how I worked this out, 7 is going to be the one that goes in the middle. Using that property that's our commutative property of addition. So we got 7x squared y z squared. Now, the reason I put that in that particular order is that we're going to factor out now a GMF. So here in orange, we're going to take out what's in common, or a GCF. What's in common to all three of those terms is a z squared, right? So what are we left with? X to the fourth plus 7x squared y plus 10 y squared. And then our next step after that will be to say, I see two variables. Let me ignore that second variable, right? Let me pretend like this is just in terms of x. So what do we have here? We've got x squared because of the x to the fourth. That's a sort of an extra curveball on this one. X squared times x squared would give me x to the fourth if I did my first times my first in that FOIL process. And then let me look for two factors of 10 that add up to give me 7. Have you spotted them? They're going to be a 5 and a 2. And then lastly, remember that curveball where we said if there's two variables, you can ignore temporarily the second variable? Now we're just going to put that back in our answer, and we should be able to FOIL it out and then get back what we started with. So I hope you found this screencast helpful. Make sure that you practice a lot of these examples, and you will get pretty good at factoring basic trinomials. Thank you so much for watching, and let me know if you have any questions in class.